let's go down each column as we simplify each polynomial and classify it based on degree and number of terms. So the very first one we have is x squared. And there's clearly not really anything to simplify because it's already just a single term. So there's no work to be done with simplifying. All we can do is classify. This has a degree of 2, and we know that that's called quadratic as we look at our list. It has just one term, so it's a monomial, a quadratic monomial. Going down, the next thing also has just one term, so it's also already simplified. And this one has absolutely no variables. When there are no variables, we have a degree of 0. So we can call this thing a constant monomial. The second word didn't change because it still has just one term, but the first term did change because the degree is different than the previous problem. Now, 5x squared wise is kind of interesting. It's still just one term. There aren't any plus or minuses separating any of those pieces. So this is also going to be a monomial, but the degree is a little tricky. Remember when I don't see a power on a variable, there's an invisible 1 there. So the degree of this monomial is 2 plus 1, or 3. It has a degree of 3. So we would call this a cubic monomial. Let's look at the second column. In the second column, we have some work to do because we see lots of parentheses. Notice the first set of parentheses, it's really not doing anything. So it's just 7x plus 4. But the second set of parentheses is making sure that we realize that both of those terms need to be subtracted. So we have negative 9x squared plus 3. Now we need to go through, we need to look for like terms, and we need to put things in order from highest power to lowest power. Now the only like terms I see are the positive 4 and the positive 3. The other two terms are each their own kind of thing, so they won't get combined. So I have negative 9x squared, a positive 7x, and a positive 7. That's my simplified form. So now we're ready to name it. Notice the first term has the highest power. It has a power of 2. So just like the problem next to it, it's quadratic for its classification by degree. But this one has 3 terms. Notice how there are 3 pieces separated by plus signs. So this is a quadratic trinomial. The problem right below that doesn't have any parentheses to begin, but notice a whole bunch of things are being subtracted with that set of parentheses. So I'm just going to rewrite it. 5x cubed plus 2x squared minus 4x cubed plus 3x squared and minus 1. The sign on each of the things inside the parentheses needs to change because each of them was being subtracted. Then I look for like terms. I've got an x cubed here and an x cubed there. I've got an x squared here and an x squared there, and then that lone negative 1 down at the end that doesn't have anything to combine with. I know I want to get to standard form, so I'm going to start with the highest powers first. So 5x cubed minus 4x cubed is just 1x cubed, or x cubed. 2x squared plus 3x squared is a total of 5x squareds minus 1. So that's what my polynomial looks like in its simplified form. The highest power is 3, so we can call this thing cubic. And just like the problem above, it has 3 terms, so it's a cubic trinomial. Below that, we see something that has 3 terms currently, and as I look at the powers on the variables, they're different. So we actually don't have any like terms at all to be able to be combined. It's still going to be a trinomial when we get done. But currently, it's not in standard form because the highest power is down here in the end. That needs to move up to the front in order for this to be in standard form. So I have negative 9x to the 4th and positive 6x squared and then positive 7. It doesn't really get much simpler than the way it was in the beginning. It's really just been put in order. Notice the highest power is 4, and we call things with a degree of 4 quartic. So this is a quartic trinomial because the highest degree is 4 and it has 3 terms. Let's tackle the third column. In the third column, we do have a set of parentheses, but interestingly, they kind of don't accomplish anything. When I think of distributing a positive 1, nothing happens. This is just 9x to the 4th plus 11x minus 5x to the 7th minus 5x. So the next question is, do we have any like terms to combine? I see an x to the 4th, and then I see two terms that each just have a linear x, and then I see an x to the 7th. Well, the x to the 7th is the highest degree, so that will come first, negative 5x to the 7th. The 9x to the 4th has the next highest degree, so it comes second. And 11x's minus 5x's leaves 6x's, so plus 6x. Oops, I should have written a 4 there. So that's the best we can do for simplifying. The highest power we have here is 7, and we don't have a fancy word we have to memorize for that, so we're going to call it a 7th degree. It's a trinomial, like many of the other problems we've looked at, because it still has 3 terms. So we call it a 7th degree trinomial. The next one has no parentheses, but starts out with 3 like terms. 4 plus 5 plus 10 is 19x's minus the number 12. This is a linear because it has a highest power of 1, binomial because there are 2 terms. Our last problem is just one term. Notice there's no plus or minuses in here, so there aren't multiple terms. So this is going to be a monomial. But look carefully. I have x to the first, y to the first, and z to the first. So 1 plus 1 plus 1 is 3. So this has a degree of 3. So this is a cubic monomial. Oops. And it was simplified in the first place. Flipping the paper over to the back, we're going to do a little bit more of this simplifying and classifying. 8 plus 7v squared. Those are not like terms, so we can't combine them, but we can and must reorder them. This is 7v squared plus 8 because the highest power has to come first. The highest power is a 2, so we call this thing quadratic, and it has 2 terms, so it's a binomial. Next, we have 2 terms in parentheses, but they're just being added together. And addition or multiplication by a positive 1 does nothing. So I can just rewrite this problem without any parentheses. That lets me see which things can be combined and have the flexibility to actually combine them. I see an x cubed here and an x cubed over there for a total of 5x cubes. I see an x squared here and an x squared there for a total of negative 3x squareds. I don't see any plain x terms, but negative 8 and positive 10 make a plus 2. So that's the simplified form. This is cubic because it has a degree of 3, and a trinomial because the answer has 3 terms. Now the last one, I can't do anything to simplify. It's already in standard form because the highest power comes first and the lowest power comes last. And none of those terms have the same variables in the same combination, so it's already done. It's been simplified. This is a quadratic trinomial because it has 3 terms with a highest power of 2. All right. We can also use polynomials to model little algebraic situations. So it says the perimeter of a triangular park is 16x plus 3. Okay, as soon as I see the word perimeter, I'm thinking, well, that means I'm supposed to add up all the sides. But there's a mystery side. So that mystery side is something I'm looking for. So if I'm going to add up each of those sides and the total is going to be 16x plus 3, to find that mystery side, because I'm asked what's the missing length, I can take the total and subtract each of those sides. Notice I used parentheses because I want to be sure that I subtract the entire side and not just the first term. Rewriting without parentheses, 16x plus 3 minus 5x plus 1 minus 2x minus 5. And then we can combine our like terms. We have 16x minus 5x is 11x, minus 2 more x's is 9x. And then a positive 3 plus 1 is 4, minus 5 is negative 1. So the length of that missing side is 9x minus 1. That might not be a very satisfying answer, but that is what they're looking for. This is all being described in terms of algebra. Similar problem here, except we're talking about a trapezoid. We want to remember that a trapezoid has 4 sides. It says the perimeter of a trapezoid is 39a minus 7. 3 sides have these lengths, 3a, 5a plus 1, and 17a minus 6. What's the length of the 4th side? Notice this is exactly like the triangle problem, just with more sides. So we start with the total of 39a minus 7, and from that we'll subtract each of those sides. And I'm just putting each of them in parentheses to be consistent, even though that first side probably doesn't need any parentheses. So now let's simplify. 39a minus 7 minus 3a minus 5a minus 1 minus 17a plus 6. Let's get all those like terms. 39a minus 3a would be 36a. Minus another 5a would be 31a. Let's see, minus 10 would take it down to 21, and then minus another 7 would take it to 14. So that's going to be 14a. Negative 7 minus 1 is negative 8, plus 6 would be negative 2. So that missing side has a length of 14a minus 2.